This is number 73. It asks, what are valence electrons? So valence electrons are the outer shell electrons that are the furthest away from the nucleus that are outside the core of the electrons around the nucleus. So if you're looking at an electron energy chart, if you had 2 electrons in the 1s, 2 electrons in the 2s, and 1 electron each in the 2p, the highest energy level would be energy 2. And you take the s and the p electrons from that, and those would be the valence electrons. So we'd have 1, 2, 3, 4, 5 valence electrons. You can also find the valence electrons just by looking on the periodic table and finding out what group or family something's in. Group 13 has 3 valence electrons in each element, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8 valence electrons. Back over here, group 2 has 2 valence electrons, and group 1 has 1 valence electrons. We usually skip these right here because they've got these 2 valence electrons right here, and then they have d sublevel electrons which aren't involved in chemical bonding, which is one of the principles of valence electrons, is that those are the ones that are involved in bonding, sharing, or stealing from one another when they stick together with something else. Letter B, what are core electrons? So these are the electrons that are inside the valence electrons. So if we had a 1s2, 2s2, 2p6, 3s2 electron configuration for the element magnesium, for example, these would be my valence electrons because they're the ones furthest away from the nucleus, and they're in the s and the p level, and they're involved in bonding. There would be 2 valence electrons here. All the rest of these would be the core electrons. And if you wrote the abbreviated electron configuration for something like magnesium, you'd put the element neon in brackets, and that would symbolize the core electrons right here, and then you'd write 3s2. These would be the valence electrons. Another way to know the valence electrons is to know that these make a noble gas configuration, and those are the atoms, the electrons that are closest to the nucleus in the core. Letter C, what does each box in an orbital diagram represent? So each box or each line represents an orbital. So if we were doing a 2s orbital, this would be one of the orbitals right here. If we were doing a set of 2p orbitals, you'd have 3 blanks or 3 boxes. And then lastly, what quantity is represented by the half orbitals in each? So if I put 1 half electron in each right here, these each would represent 1 electron in each orbital. These would have what's called an up spin, and then if I draw it this way, these would have a down spin. And remember, the rules always say that 1 electron gives in each orbital before they pair up, and then when they do pair up, one has to have an up spin and one has to have a down spin. That's number 73.